Hi, welcome back or welcome to my YouTube channel for data analytics. We've been talking a lot about Alteryx and how Alteryx can help you manipulate your data, store data for reporting. And I thought I would take some time and produce a series of videos that sort of rounds out my SQL training classes that I've taught over the years. Originally, when I started teaching my SQL training classes, the business analysts didn't have a nice tool like Alteryx to pull their data in with. They had to do all that by directly manipulating their data within the database. Typically, and primarily, that meant using the SQL select statement. This was foreign to a lot of people. It also meant that they had to learn a new way of thinking about data and thinking about structures. So the SQL language is there for a purpose, and it is to enable you to directly interface with the RDBMS that provides your data. This class is going to take a different slant from the overall content of what I've done in the past, because a lot of what I had to teach people to use with the SQL language for, Alteryx will do for you, and you can allow Alteryx to make decisions and to assist you. But there are things that Alteryx cannot do. There are still things that you have to interact directly with the RDBMS for, and that's what this class is going to try to bring about. The first thing you have to understand is, what is an RDBMS? And what RDBMS are you using? RDBMS stands for Relational Database Management System. And some of the primary providers in this arena you've heard of: Oracle, Teradata, Postgres, MySQL, SQL Server, and of course IBM's DB2. If you're fortunate, your company has been able to adopt a standard, and you only have to deal with one RDBMS, both for your data extractions and for your data reporting. However, due to software as a service, third-party applications, and other considerations which your company cannot control, your data probably resides in more than one RDBMS, and the data that you're storing is probably being stored in a different RDBMS. For the purpose of this class, I'll be using MySQL as the source and target for my data workflows and all the examples for the SQL select statements and other data management commands that we'll be issuing. Where possible, I'll talk a little bit about Oracle and Teradata, as those I've been using more than others in my career. But understanding how they differ from MySQL and from each other will help you understand how they also differ from the SQL Server and other databases. If you're using Alteryx and you're accessing data, and the data is in any RDBMS or multiple RDBMSs, first thing you'll need to do is make sure that you have the RDBMS's access tool installed in your workspace. For MySQL, it's called Workbench. It's freeware software, and pretty much all of the access software is freeware, because otherwise how can they sell their RDBMS if they also make you pay to have to use it? There are third-party applications that access multiple databases, such as the Toad suite of query tools, as well as Aquadata Studio, and a few others that people use. But if you're only dealing with one RDBMS, even if you're dealing with multiple RDBMSs, it's always good to have the native application available to you, because it might show you things or interact differently than some of the general tools. So go ahead and make sure you have and can install your RDBMS tool, because this is how you're going to be able to talk to the RDBMS that you use in order to get information to navigate and to manipulate your data stores. And you notice I said talk to. A few years ago, as I was teaching a number of technology classes, people asked if I knew other languages other than just English, such as Spanish, German, or French. And realistically, I don't. In high school, I learned French. I know enough about French to be extremely dangerous. I've tried to learn Spanish, but I've been laughed at because my Spanish sounds a lot like French. And I often wondered why I hadn't learned multiple languages. But then I suddenly realized I know a lot of languages. All the languages that I have learned are computer languages that I code in, talk to systems, do data manipulation, and other processing. Some of those you've heard of, some of them you may not have heard of. This is by not an inclusive list, nor is a list of all the languages that I know. I know about 8 to 10 computer languages, but Fortran, Basic, C, SQL, and Java are all languages that are used to talk to computers. SQL specifically is designed to talk to RDBMSs and manipulate your data and retrieve data for you. So you will be learning a new language when you begin to learn some of the SQL structures. Always like to point out a brief history of the SQL language. It all started quite a while ago when IBM first came up with System R, which is a relational database system, and they called it SQL, which is how we pronounce SQL. They discovered that SQL was trademarked and they could not use it. So rather than change a lot of things, they renamed it SQL, which was structured query language, and it's pronounced SQL. One of the nice things is that there is an ANSI standard for SQL, the language, as well as there is for Fortran, COBOL, and other languages. The bad thing is that about 10% of the SQL language that your RDBMS talks is not standard. That causes lots of fun when you're switching between RDBMS and RDBMS. Primarily, with what we're going to be talking about in this class, the code that we'll be looking at applies across the board, with a few minor modifications here and there. Where possible, I'll point out differences in MySQL, Oracle, and Teradata just to give you an idea of what you might be doing in your own environment. The web is a great place to find some of these differences to translate between one and the others, and I recommend that you get very confident with searching through Google. I recommend always choosing the name of the RDBMS in your search. For example, if you want to find out about a where clause, you would say SQL where clause, MySQL, so it will bring up references strictly to MySQL. One of the things to talk about is why do you want SQL and Alteryx? As you're very much aware, Alteryx is pretty much database agnostic. Once you bring your data into a workflow through one of the data preparation widgets, Alteryx no longer cares where that data came from, nor where that data is going to. The primary places that you'll be concerned about the differences in RDBMS and understanding what your RDBMS can do is the biggest one, which is the in-database widgets, because you may need to be cautious as to how you use them and how you code some of the structures within these widgets, because they are very much database dependent. And then obviously your input and your output. Also know how to get to an RDBMS. 95% of the time, Alteryx is making great decisions on how to get your data and how to put your data through its input and output data and translating between RDBMSs. But you need to be careful in certain situations, especially if you run into an error. You need to look into why that error is occurring. And there's some other minor issues that show you why you need to do it. The first one we want to talk about is a data catalog. Every database knows about all of its tables, columns, views, and other structures that were within their environment. Alteryx also tries to understand some of that, but it's not always very efficient or very collectively proper when it deals with some of the different RDBMSs. So for example, one of the things I discovered is when I was going into MySQL, over here is a list of tables. These are the tables that Alteryx has found inside of my MySQL database. However, it's not really all of them. It happens to be all of the tables that are in my default database. Even when I hit refresh, it will only pull up those tables that are inside of my default database, not all the other databases that are available within the MySQL environment. However, if I go to MySQL Workbench, you see that over in the schemas and the navigations, it'll show me not only the Daisy Hill, which is where all those tables come from, but I'm also working on a financial system, and these are the tables that I'm currently have available within that financial system. So if I didn't understand a little bit more about my RDBMS and how tables are broken up into schemas, I might not know how to find or to reference these objects. That's where the SQL language comes in, and the knowledge of the SQL language. Obviously, there are other places where you need to understand SQL and go directly to the RDBMS. I summarized them up basically in this section. We just talk about the first one, investigating the data catalog. Every RDBMS knows about this table's views and columns. They have tables and views that let you know that information, but they differ from RDBMS to RDBMS. So for example, in MySQL, it's in an information schema. In Oracle, they have database views that allow you to directly reference through synonyms the data catalog. For example, it has user tables, user columns, as well as all tables and all columns. And you didn't understand the differences between them, but it makes it a little bit easier to get to the data catalog in Oracle. And in Teradata, there's an actual database called DBC that has in it a whole slew of views, and you just have to understand which views are the ones that you want to use that have the best data or the proper data for you to do any kind of catalog search. What else you might need to use SQL directly for is to try to verify your workflows. Did your workflow properly translate that data, or did it make a mistake somewhere along the way? Having the ability to query and do some basic manipulations of your data at the RDBMS will let you know if your workflow is indeed successful. Alteryx does not give you the ability to perform any kind of table maintenance. So any table maintenance that has to occur, you have to do manually. That would be things like adding indexes, reorganizing the table storage, or granting other people permission to use your table within your environment. A couple things we talked about there briefly is how to implement table performance enhancements, not only indexes, primary keys, alternate keys, and other constructs such as structuring your data storage will have to be done directly with the RDBMS. The same applies to any kind of data integrity constructs that you want to have, such as not null columns, columns having certain values, as well as foreign key relationships and primary key constructs. All are not provided by Alteryx. You must provide them yourself. A whole nother topic is dealing with the semantic layer, which is views that are instantiated within your database that provide easier access as well as security and other access considerations. If you want to build that semantic layer and to maintain that semantic layer, you have to do it directly. Alteryx can query through and insert into using views, but it's up to you to create those views. And finally, if you've been following some of my videos, we talked about the heavy lifting queries. If your data is so large that you cannot realistically bring it down into Alteryx in order to find just the records or to join just the records that you need, you have to get the RDBMS to do that for you. That involves typically in writing a simple join query that will limit the amount of data that's brought down to Alteryx. Then Alteryx can do the continued processing from there. But that query needs to be vetted and tested by you through the SQL select statement or in your RDBMS. It's a pretty lengthy introduction. Here's where I'm headed. 6 parts in this right now that I see. This can change at any time as I go through it, but I pretty much digested all the SQL classes I've taught in the past and decided the best way to put this. We'll talk at the beginning a little bit about some basic RDBMSs, how to connect to them, how to make object names, and referencing those object names, about data catalogs and data types, things that you need to understand from MySQL basis, but also I'll make reference to what other RDBMSs have available so you can figure out how to translate between them if you need to. We'll look at a basic SQL select statement, how to code it, how to execute it, how to look at the results, some of the basic clauses that you would use. In part 3, we'll detour from there and take a look at multi-table joins. One table never has your data. How do you join multiple tables together? What is an inner join? What is an outer join? What are things that you need to be concerned of? What are the rules? How to code it? We'll look at some of the other SQL commands other than the select statement that allow you to do your object management, such as if you have a table that you no longer need, you must drop it manually. You cannot get Alteryx to drop it for you. Or if you do get Alteryx to drop it for you, you have to create the SQL statement because Alteryx does not have a native drop table command or widget. To flesh this out and get a little bit more complex, we'll talk about many ways that you can join tables when some of the basic table joins don't work for you. Hopefully you never need to use these, but it's nice to mention them and talk about them just in case they are the consideration of how you have to do your heavy lifting on the database. And finally, we'll talk about some of the other constructs that can also help you reduce the data down and other ways of looking at your data, such as with unions, intersections, and minuses. This is a work in progress. Please subscribe so you can see each piece as I release it. Part 1 should be coming out soon. If you have any questions, any concerns, anything you would like to see in any of these pieces, please put a comment and I'll answer you as soon as possible. Have a great day.